In this problem, we want to use the half angle formula to find the exact value of the sine of 105 degrees. 105 degrees is not a measure that we know on the unit circle, so we can use the half angle formula to try and solve this for us. So the sine of 105 degrees. So when we're trying to solve this problem, we have to first consider whether we're going to be using the positive or negative version of this formula. Because if you recall, the formula looks like this. The sine of theta divided by 2 equals plus or minus the square root of 1 minus the cosine of theta all divided by 2. So we have to figure out, are we using the positive or negative version of this angle? And that is all dependent on whatever our angle is and whether the function that we're trying to evaluate at that angle measure is positive or negative. So 105 degrees, that's an angle measure in quadrant 2, which in quadrant 2 the sine is positive. So that means that we're going to be using the positive version of this, formula. So let's go ahead and use the half angle formula. So we're going to rewrite the sine of 105 degrees as 210 degrees divided by 2. So 105 is half of 210. Now, why do we want to write it this way? Well, 210 is a value that we know on the unit circle. So when we are evaluating the cosine there, it's going to be a value that we know and can actually find the exact value for. So that's why we're going to write it in that way. So let's go ahead and just plug into this equation. So this right here, 210 over 2, this is essentially just theta divided by 2, where theta is 210. So when we're evaluating the cosine of theta, we're going to evaluate the cosine of 210 degrees. So the sine of 210 over 2, again, we said we're going to use the positive version of this formula because the sine is positive in quadrant 2. So it's positive square root of 1 minus the cosine of 210 degrees, all divided by 2. 210 degrees is an angle in the third quadrant, and the cosine is negative in the third quadrant. So the cosine of 210 degrees is rad 3 over 2, negative rad 3 over 2. So this is the square root of 1 minus negative square root of 3 over 2, all over 2. We're subtracting a negative here, so we can just take this as a sum. So 1 plus the square root of 3 over 2, all over 2. And we probably should get rid of our fractions so we can multiply numerator and denominator by 2 to get rid of the fractions here. So that's going to give us, distributing through in the numerator, 2 plus the square root of 3, all divided by 2 times 2 is 4. All of this in the square root. Now, if you recall, if you have something like this, the square root of a over b, we can just make this the square root of a divided by the square root of b. We can break it up into a quotient of 2 radicals. So I'm actually going to do that here because it's going to help us reduce this. So we're going to have the square root of 2 plus the square root of 3, all divided by the square root of 4. And the square root of 4 we know is just 2. So in all of this, the sine of 105 degrees is equal to the square root of 2 plus the square root of 3, all divided by 2. So this is the sine of 105 degrees. Again, using the half angle formula.